Go ahead. All right. Hello, I'm Toby Ford with AT&T.
Hi, I'm Haseeb Akhtar from Ericsson.
And today we're going to talk about autonomous network management, trying to achieve some level of nirvana with automation. So there's this concept this guy named John Boyd came up with in the 40s and 50s. He was an Air Force strategist, and he was trying to come up with a way for him to train fighter pilots who are going now faster and faster and dealing with more and more inputs and more sensory phenomena. And so he came up with this sort of rigorous way of quantifying what happens when you're in a dogfight and what do you have to do. I find this to be very helpful when we deal with solving problems in both in the IT realm and in the telco realm. And what we're finding is, as people have a problem, they want to see it get fixed. And then shortening that feedback loop between I have an issue and I get it solved is really the key problem that we're trying to solve. And then of taking it from being a reactive thing, from starting today with manual processes and with more manual interactions, and transitioning really to something that's far more proactive and automatic. So this is the basis from what I'll talk about is this feedback loop, or this what we now refer to as a closed control loop. In the work that we're doing at AT&T and sort of introduced this morning called eComp, in our orchestration and control platform, we're trying to instantiate a mechanism to manifest many of these overlaying control loops so that we can take policy that manifests people's needs and desires and their expectations, whether it's about resiliency or about, let's say, CIR or how much bandwidth I get or any sort of quantification of what my expectation is. And then I take that and then I work to create control loops around that policy so that then I can observe, I can take all of what I know and what I've known from the past and some level of sort of machine learning, and you add that and you filter the problems that you see through that kind of cognitive sort of map, that neural map, sometimes other logistic regressions, other mechanisms to actually make it so that eventually the things that I decide and act on are done in an autonomous way.
Thanks, Toby. So what we're going to show today is an instantiation of what Toby just mentioned. In the last OpenStack summit in Tokyo, what we did is we successfully stood up a VNF, a Telco VNF, using Apsara container, which was fully integrated with OpenStack. And this Telco VNF was a virtualized web communications gateway, or WCG. What Web Communication Gateway does is basically it sits between an HTTP-based browsers and a SIP-based network so that the browser-based clients can have access to the SIP-related sessions. So that was the objective. And we actually did that successfully in the last OpenStack Summit. And what we want to do in this demo today is we actually want to take 3 network elements and collect network observability metrics from those elements, and then create an efficient feedback loop as mentioned by Toby in the same manner that John Boyd came up with in terms of the control loop. So these network elements that we're going to look at is, of course, our OpenStack, where we're going to get the compute storage and the networking data from OpenStack Ceilometer. And then, of course, then next we'll be using the Apsara container, where we're going to get 2 kinds of data. One is the workload-based data, and the other part is the platform-specific data. So the difference between the workload and the platform would be that the VNFs that you would be running on the container, plus all the resources that the container would be responsible for across the multiple data centers or even the single data centers that it will stand up. And finally, the VNF itself, where we'll get some error information, in terms of the user or the network that the VNF is experiencing, as well as the memory and the other usage that it has. So using that, what we'll first show in the use case 1 is that if any one of these observability metrics goes above the threshold, then we will create another VNF. So the Apsara container will stand up another WCG on the single data center so long we have resources available in the same data center. However, we'll go to the next use case by putting more traffic on the network, more users on the network, and then we'll eventually see that the resources in the data center that we were hosting all the VNFs from gets depleted. Then we'll move to the secondary, another data center, and then the Apsara container will then stand up another WCG into our second data center. And this one we would be using a public cloud. We actually happen to use the Amazon's public cloud to stand up using the container this WCG. And just to make things, or put things in perspective, these are all done in a very autonomous manner that you will be seeing in the demo. And this cloud, the first database is actually in our Ericsson's Montreal lab, and the second data center would be in Amazon, wherever they happen to host it. So let's just start the demo.
Let's begin with the Workload Observability Manager, which collects and processes relevant metrics from various cloud platforms and deployed VNF. In our case, we have two platforms for this cluster: Ericsson Cloud, based on OpenStack, and a public cloud hosted in Amazon AWS. The workload information displayed on this dashboard is about VNF CPU, disk, RAM, networking usage, as well as error events related to the VNF service layer agreement. The error events are due to user registration signaling or media drops due to lack of capacity. The error events indicator is one of the most critical SLA indicator. When the system experiences more than 1% of error events, the observability manager needs to take action in order to secure the SLA. We'll now only show the error events metric to see how the system handles this indicator. We are going to stress the system by setting the desired number of users to connect to our network, as well as choosing the workload constraints. These conditions are reflected now in the stress test panel. As VNF1 ran out of resources and the error events goes above 1%, the observability manager requests from the platform to scale up by adding a new VNF to cope with the traffic needs. As you can see, the observability manager scaled the system with VNF2 almost immediately after the critical alert. Because the system just scaled, there are no error events. Now, let's show more metrics for workloads, such as VNF RAM. You can see now more VNF metrics performance. As we can see, when one of the VNF RAM reach 80% of capacity, the observability manager requests to add a new VNF workload in order to distribute the traffic load. The scaling is done after the critical alert in red coming from the observability manager and indicates that the current VNF is running out of resources. The next blue and green logs show that the system handled the situation by scaling the telco ecosystem with a new workload. When the private cloud informs the observability manager that there are no more resources available for the requested workload, the system decides to burst to public cloud. Let's see now the critical logs. The first one is in red and is about VNF3 running out of resources. The next one is in purple, Ericsson Cloud running out of RAM, and cloud bursting is requested. Finally, dark green and blue logs informs about the clouds bursting. Based on the alerts, the VNF4 is deployed in Amazon Cloud, and the traffic is distributed between the available workloads on different platforms. We will now see how the system handled the number of user constraints up to 4,000. Now, let's see how the system handles overcapacity. In order to achieve this use case, we'll stop the traffic. When the system detects that there is overcapacity, the observability manager starts to scale down by removing first workloads running in public cloud, and then removing those running in the private cloud.
Okay, that's the end of the demo.
Yeah, so I mean, as always, the goal is to shorten the feedback loop and then to meet the customer's expectations. And they want to know that something's fixed as quickly as possible. And then in this example, container technology helps to even do that further than what a VM or a virtualization mechanism would do.
Yeah, and then it's really important to take observability data from all possible network components. As shown in this demo, we actually use the data from the OpenStack Ceilometer, from the VNF itself, as well as from the Apsera container to achieve a very expedient and efficient feedback loop.
Yeah, so I'll conclude with, I would urge everybody to read the eComp white paper and then look at some of the blog entries. We're going to start to gradually give out more and more information about what we're doing for orchestration and control policy-wise, and I urge everybody to take a look at that stuff.
All right, thanks for watching. Thank you very much. Appreciate it.